example is really similar to work example 4, so it might be an idea to copy down your question and then have a go at this first, and then just fast forward the end, see if you got the right answers, or if you're still not sure, I'll go through the whole thing as well in a similar way. So first thing we're going to do, we've got the vector O to A is defined as the vector A, and O to A is this vector here. Oops, do that better. There's O to A. In green, the next one there is O to B, which is B. So O to B. Okay, and then the last one, I do that in purple, is O to C. Now if you're not wanting to use colours, which of course you don't have to, you can just label them. So you could label this, with your pen as, you could have A, B, C, just so you can see which one's which. Okay, M is the midpoint of the line between A and C. N is the midpoint of OC, which is this one, so there's a point there, and P is the midpoint of OB, so it's just going to help us to define a few things later on. Now we're going to be finding in terms of A, B and C, those three vectors, A to C, O to M and so on. So let's have a look at the first one. We've got A to C. So having a look at the diagram, to get from A to C, what we'd need to do is to either go straight across, which we can't do. We've got no information about these so far. What we can do is go this way. So we can go travelling backwards up the blue vector, which is negative A, travelling backwards up A. Then we can travel the correct way down this vector O to C, which is the vector C. So negative A plus C. The next one that we're looking at is we're wanting to go from O to M. So if we go from O, which is this point here, to M, which is this point here, what we're going to need to do is now figure out how we get there using the information that we know. Now so far we actually know, and we haven't written it down, but we can do that in blue, that A to C, this vector here, is negative A plus C, or if you like, and it looks kind of nicer, C minus A. So that's C minus A going across there, that whole vector. Okay, so let's try and construct now for B, O to M. You can see that for starting O to get to M, we'd have to first of all go down B. Okay, so we're going to have B. And then we would have to think about how do we get here? Oh, well, we're kind of stuck. So that's not the best way to do it. So let's go, what else can we do? Oh, we can construct it using these side ones. You could go that way, or that way, makes more sense this way. So we'd go this way, A. Okay, and then we would be going to get from O to M this way. But we're not going the whole way along, we're only going halfway along. So that would be A, and it happens to be oriented the right way, plus a half of this vector A to C, which is A plus a half, and we know what A to C is because we did that up here. What's that? Now scalar, we use the distributive law for a scalar outside a bracket with vectors, so this would be A plus a half C minus a half A. We're just expanding that a half out to both things. A minus a half A, that would be a half A left over, positive a half A, plus a half C, as well. So that would be our vector for O to M. So going from the point O all the way to the point M is A plus half of this vector, half of C minus A. The next one, C, we've got C to N. Now if we look at C, and I'll just erase some of these lines here so we can see better. Oops. Okay. If we're looking at this next question, let's put that one back, we've got C to N, which is going from this point here backwards along the purple line to get to N. And we know that purple line is C. So first of all, we know we're going backwards, which is negative. We're also only going halfway to get to N. So halfway there would be negative a half of C. And I'm actually going to write that in there. You could write that if you wanted to as negative C on 2 as well. I just think that looks kind of ugly, I guess. So I sort of prefer writing it that way. Okay. So negative because we're going backwards up that line. Only 2 left. D, M to N. M to N is going to start here and go along. Now the thing that we know, and I'll do this in red, we found out this, well, vector here is c minus a. This little part here from m to c would be a half of that c minus a. So that would be the red vector there. So now if we wanted to travel from m to n, we know we'd have this little red vector, so a half of c minus a, and then we'd be travelling this way. And actually what I might do, sorry, so I'll just write it, I'll write it in terms of the points first, so m to c plus c to n, which is, so m to c is a half c take away a, and now I've got a bit more room. And then we know that c to n, because we found that in the previous question, is negative a half c. So we can expand out, again, distributive law. So we have a half c minus a half a minus a half c. A half c minus a half c, well, those two things will cancel out. So we're just left with that minus a half a. That's what mn is. So m to n straight up is negative a half of a. The next thing, and actually I might put that, it can be a little bit, it's getting a bit crowded in there, so I might leave it. The last one I'm going to do now is e. So we've got m to p, m to p, which is here. Now let's have a think what we've got. We're going to be travelling, and I'll do the travelling here in yellow. Going to travel along m, up this way, and then down this way to p. That makes the most sense as a way of getting there. So in terms of what that will be, we've got this little red vector that we know is a half, oh, I should do it again, mc, plus all of this vector here, which is c to o, and we know that's actually backwards c, plus this little vector here, o to p. So in terms of what those pieces are, m to c is this part here. M to c is a half of c minus a. CO is actually c, but it's the wrong way, it's backwards, so that's minus c. I'm just ticking them off as we go. And O to P, we know that this vector here is B, and this is only half. We know it's half because P is the midpoint. So to go from O to P is going to be plus a half B. So expanding this out, we've got a half C minus a half A minus C plus a half B, a half of C, and we should have the tildes on there. A half of C minus C is negative a half C minus a half A plus a half B. And if you wanted to, a nice thing there, I've nearly run out of room, would be to factorise that half out the front. So you'd have negative A plus B minus C inside the brackets. And you could even take the negative out in front of the A and C if you wanted to, but that's the answer there to go from M to P using the vector quantities that you already know as you work through the problem.